Hi grade 9s, today's lesson starts topic 3, which is the quadratic equation. Now this is the first stuff that is new to us because this is a grade 9 topic. Now we're starting with 3.1, we're going to start with the basic quadratic equations. They're really important equations and they're new to us, and so we're going to go a little bit slowly in this section, and 3.1 is going to be our basic examples. And then once we've practiced our basic examples and we're feeling confident, we'll move on to 3.2, which is the slightly more complicated ones. So, the whole of quadratic equations are completely different to what we call linear equations. Now, every example up until now has been called a linear equation. So, what makes something a quadratic equation as opposed to a linear equation? A quadratic equation is going to have an x squared in it, whereas a linear equation only had an x in it. So up until now, every equation we've solved has had just plain x. It hasn't had any x squareds. So this is a completely new field for us. Now, because it's a completely new field, it means we solve it in a completely different way. Now let's look at linear equations. What was the main focus with linear equations? In linear equations, we wanted letters on the left, and we wanted to get all the numbers to the right, because when we isolated x all by itself. So whenever you think of linear equations, you should always think that the basic program that you try and follow, the basic method you try and follow, is letters to the left, and then you get rid of all of your numbers slowly towards the right. Now in quadratic equations, we're not going to do that at all, and we'll see why. Now quadratic equations all hinge on this idea of what I've put in a box, and that says that if you have a multiplied by b and it equals 0, what do you then know? Well, how could you possibly multiply two things together, two numbers together, and get 0? Surely then one of them must be 0, because there's no other way to multiply together to give you 0 unless either a must be 0 or b must be 0. Now think about that for a second. That's not true for any other number in the world. If this said a multiplied by b would give me 6, for example, that doesn't mean that one of them has to be 6, because 2 times 3 gives you 6, and neither of them are 6. So this is the only number in the world where if you have things multiplied together to give you 0, one of those factors has to be 0. The only way to multiply together to give you 0 is something times 0. Now, if a was 0, then b could be anything in the world, because as long as you're multiplying by 0, you would get 0. Now, this is actually called the Zeroth Law, and it's basically the whole premise of quadratic equations. So let's do a whole bunch of examples. So, first question says solve for x as normal, and question A says x, and then in brackets x plus 3. So, if we thought of this as like we think of linear equations, we would be tempted to multiply out. So that is our first temptation here. Now there's nothing wrong with that, because we don't really know how to solve this yet, so let's try. If I multiply out, I get x squared plus 3x. Now if I have a look at this, this is a classic quadratic equation. Why is it a quadratic equation? Because it has an x squared. Now if we try to follow the same process as a linear equation, we would say get our letters to the left. Now all my letters are on the left. Then I would say get x by itself. Now here's the problem. I can't get x by itself because I've got an x squared and an x, and I can't add them together. If I try and get rid of 3x, then the 3x moves to the right hand side, and then I have x's on both sides, which is even worse. So this is why our linear approach completely falls down, because I can't get x by itself, because x is in multiple places, but they're not like terms, so I can't add them. So this leads us to a new approach. So this didn't work. So in future, I'm not going to just launch into multiplying out. I'm first going to think about it. So let's go back to the question. If we go back to x plus 3 equals 0, what can I tell you? Well, let's think about this zeroth law that we just learned. We just learned that if you have two things multiplied together to give you 0, one of them has to be 0. So that either means that x has to be 0, or it means that x plus 3 has to be 0. Now, if x is 0, you've found the value for x. If x plus 3 is 0, you haven't found the value of x yet. So if I subtract 3 on both sides, so it disappears on the left, and I subtract 3 on the other side. Now what's landing up happening here is I have two answers for x. Now that always happens in a quadratic equation. A quadratic equation always has two answers for whatever variable you're finding. Now let's check, does this actually work? Well, let me change color quickly. What happens if x was 0? What would I get? If x is 0, I would get 0 multiplied by 0 plus 3. Now that would be equal to 0 multiplied by 3. Now I don't really care what's in that bracket. 0 multiplied by anything is 0. So it did actually work. What happens if x is negative 3? Then I would get negative 3. I've put in my negative 3 for x, and in brackets that I have negative 3 plus 3. Now that would be negative 3, and the bracket would be 0. So it doesn't really matter about that negative 3, because 0 multiplied by anything is 0. So both of these worked, and they worked because if you multiply two factors together, these aren't two separate terms, they're one term, so we call them factors. If you multiply two factors together to give you 0, the only way that's possible is if one of them is 0. They don't both have to be 0, and so that's why you get two answers for x, because the one x answer makes the one factor 0, and then this will work, and the other x solution makes the second factor 0, and then it works as well. So let's have a look at a couple of examples. This is very new to us, and so it's not a problem if you feel a bit uneasy at first. So if I have a look at this, I see x minus 5 multiplied by x plus 2, and I think my instinct says multiply out. Now the moment you multiply out, I'm going to get an x squared. Now I know with x squared that it's not like a linear equation, and what's going to land up being our overall goal in a quadratic equation is going to be you want to write it as two factors multiplied together to give you 0. So there is factor number 1, and here is factor number 2. Now as long as you have two factors multiplied together to give you 0, that is wonderful news in a quadratic equation, because what it means is that either factor number 1 is 0, so either x minus 5 needs to be 0, or, not or, it's not and, because x can't be both values at the same time, so or x plus 2 needs to be 0. As long as one of these factors is 0, when you multiply you will get 0. So if I add 5 to both sides, I get that x must be 5. If I subtract 2 on both sides, I get x is negative 2. Now let's just check what happens. What if x is 5? If x is 5, I would have 5 minus 5 multiplied by 5 plus 2. So that would give me 0 multiplied by 7. And 0 multiplied by anything is 0. So it does actually work. Let's check negative 2. So I'd have negative 2 minus 5 times negative 2 plus 2. Now negative 2 plus 2 is 0. So the fact that this first factor is negative 7 doesn't matter, because anything times 0 would give me 0. And so both of these answers work. So let's look at C. This is an example of actually what's called a cubic equation. You don't only have to have two things multiplied together, you could have any amount of factors multiplied together. So as long as you have multiple factors multiplied together to give you 0, one of them must be 0. So either x minus 5 must be 0, like in the previous question. If you have a look, this is exactly the same question. I've just added on an extra factor. So or x plus 2 must be 0, like in the previous question, or x minus 1 must be 0. So because there's three factors, you'll end up getting three answers. So add 5 to both sides, subtract 2 from both sides, add 1 to both sides. So there's actually three answers that would make this multiply together to give me 0. Why? Because basically each bracket has a chance to be 0, and then the equation works. So if you had 100 brackets multiplied together, you would actually land up with 100 answers. Okay, so I'm hoping you're happy with these basic ideas of multiplying together to give you 0. So let's look at some more interesting ones. What happens if there was a 3 in front of the bracket? So we do actually have 3 factors multiplied together to give you 0 here. So one of them must be 0. So either 3 must equal 0. Now, can 3 ever equal 0? This is just not possible. So what we start to notice is that if you have a number as one of the factors, you can pretty much ignore it, because a number can never equal 0. So this is not possible. So in future, if I see a number in front of the bracket, I'm going to completely ignore it, and I'm going to say that my answer simply depends on x minus 1 could be equal to 0, or x minus 2 would have to equal to 0. Then these would multiply to give you 0. So if I add 1 to both sides, I get 1. If I add 2 to both sides, I get 2. So basically, what I'm arguing here is constant factors, I should say, can be ignored, because they can never equal 0. And they're not a problem, because if one of the brackets is 0, 3 times 0 would still give me 0. So they are completely useless and not important. Okay, let's look at E. E has x minus 2 squared. Now that's not 2 factors multiplied together to give me 0. Now it actually is in a way, because it's x minus 2 and x minus 2. So if I write it out, it is 2 factors multiplied together to give me 0, which means one of them must be 0. So either x minus 2 must be 0, or x minus 2 must be 0. So I'm still going to get 2 answers. So I add 2 to both sides, and I add 2 to both sides. Now I do get 2 answers, but they're the same answer, simply because the brackets were identical. So there's nothing wrong with getting 2 answers, whereas they're actually the same. So what it actually means is, do I have to write it twice? And I don't. If I can recognize that that factor is identical, you only actually have to write down one of the answers, because the other one will be the same. Okay, so what we've done in questions A to E is simply play around with this idea of, if we have 2 factors multiplied together to give me 0, one of those factors has to be 0. And so you give the first bracket a chance to be 0, and the second bracket a chance to be 0, and you get 2 answers. Now, every single one of these questions, I'd given you 2 brackets multiplied together. Now, in the rest of the questions, I'm not going to give you those brackets. So how do I get those brackets? So if I have a look at the next question, this is a quadratic equation, and that's my first step. My first step is always to ask myself, what type of equation is this? Because depending on the answer to that question is going to dictate your method. So if it's got only x in it, it is a linear equation. And remember, that method was letters to the left, numbers to the right. If you have x squared, this is going to be a quadratic equation. And in this example, I have x squared. So my question is a quadratic equation. So now the question is, what's my method? Now, ultimately, you want to get 2 factors multiplied together to give you 0. That is always your goal in a quadratic equation. You want 2 factors multiplied together to equal 0. So the first thing I have to ask myself is, do I have the 0? There's 2 parts to this. Part 1 is, do I have 0 on one side? And the answer in this example is yes. My second thing is, do I have 2 factors multiplied together? Now I don't. I have 2x squared plus 2x. Now that's not a multiplication. So how do I make that into 2 factors multiplied together? And that is factorizing. That's why we learn factorizing. So in order to make this into a product of 2 factors, I'm going to factorize. Now what's the first step when I factorize? A highest common factor. So if I have a look at that left-hand side, my highest common factor is 2x, and what's left behind? 2x times x will give me 2x squared, and 2x times 1 will give me 2x. And so what I've done is I've made it into a question that looks like questions A to E. So here I'm having to do an extra step to create the two brackets multiplied together to give me 0. So now I can either say, so 2x must be 0, or x plus 1 must be 0. So now to solve both of these, I'm going to divide by 2 on both sides, and 0 divided by 2 is 0, and I'm going to subtract 1 from both sides, so I get negative 1. So when we write down our steps in a moment, one of our steps is going to be factorize to get two factors multiplied together. So let's have a look at G before we write down our steps. Don't forget, I'm going to leave that little note there. What's the goal in a quadratic equation? You want to get two factors multiplied together to give you 0. So if I look at this question here, my first question is myself, is this quadratic or is this linear? Now the answer to this question is it's quadratic because of the x squared. Now this is where we need to start looking at what our first steps needs to be. Don't forget the goal. The goal is to get two factors multiplied together to give you 0. So 2 factors multiplied together to equal 0. So my first problem in this question is there's no 0. So when we write down our steps in a moment, the moment you realize something is a quadratic equation, our first step is going to be you must make one side 0. Now generally we get the right hand side to 0 because we're just so used to that. So in this particular question, this 9x needs to disappear. So I'm going to write myself a little note here. I need one side equal to 0. And I'll write down proper notes in a second. So you don't have to write this step, but to explain to you what I'm going to do is I need to get rid of that 9x. So I'm going to subtract 9x on both sides. So what lands up happening then is now my right hand side is 0, which is wonderful. So that's my first step in a quadratic equation done. So first step when we write it down in a moment, one side has to equal to 0. Now our second step is the whole aim is to get two factors multiplied together, which means I now need to factorize. Now we're going to explore the other types of factorizing in a moment, but this is once again a highest common factor. So I'm going to take out a highest common factor of 3x, and I'm left with x minus 3 equals 0. Now once you have two factors multiplied together to give you 0, the question's all but done, because either the first factor must be 0, so either 3x must be equal to 0, or the second factor must be equal to 0. And that basically makes you two little mini linear equations, but we've been solving those for ages. So I'm going to divide by 3 on both sides here, and I get x is 0, and I'm going to add 3 to both sides here, so I get x is 3. So there's two answers to my equations. Now very, very, very important here. So I'm going to write it in, I don't know what color to pick, purple. Never, ever, ever divide by a letter. Never ever divide by x in an equation. And let me quickly show you why. If we look at this example of 3x squared equals 9x, most of us will be tempted to divide by x because there's an x on both sides. Let's get rid of it. Now if you divide by x on this side and you divide by x on that side, we've always said as long as you do the same thing to both sides, it's absolutely fine. Now what happens here is 3x squared divided by x, one of the x's cancel and I get 3x. And so I get 3x is 9. And when you now divide by 3 on both sides, you get x is 3. Now are you incorrect? No, you're not incorrect, because x is 3 is an answer to this question. You have found one of the answers. The only problem is you took a quadratic equation and you made it linear. So you only got one answer. there's no x is equal to 0 that got discovered here as an answer because you destroyed it. So I'm just going to put this in a little bubble here, and we're going to write down a set of notes in a moment. Never, ever, ever divide by a letter in an equation. So up until now we've said, do anything to an equation as long as you do the same thing to both sides. Okay, T's and C's apply. And the terms and conditions are, you can do anything, but never divide by a letter. Okay, now we're going to use this next example to write down all our steps. So first step is ask yourself, is this a quadratic equation? Now, why would I know it's quadratic? It'll have an x squared. Or is this a linear equation? How will I know it's linear? It'll have an x. In this case, it's a quadratic equation because it has an x squared. So now what is my next step? My next step is, don't forget the aim. The aim is to get two factors multiplied together to equal 0. So my first kind of thing I need to do here is get one side equal to 0. So what most of us pick is the right hand side to be 0, which means I need to get rid of 5x. So I'm going to subtract 5x on both sides. So I get 2x squared minus 5x, and 5x take away 5x is 0. So notice I haven't actually written the minus 5x on both sides because we start to cut corners. So that's my first step, get one side equal to 0. My next step is factorize. You want to get two factors multiplied together to give you 0. So factorize to get two factors multiplied together to equal 0. Now what's the first thing when we factorize? We check for a highest common factor. After that, just to recap, we check for a dots, and after that we check for a trinomial. So in this case I'm going to check for a highest common factor, and I see that x is common. So I'm left with 2x because x multiplied by 2x will give me 2x squared. Subtract 5 equals 0. Now that's all the hard work done, because all we have to do now is, if you have two factors multiplied together to give you 0, we're going to use that zeroth law, which is one of these factors has to be 0. So each one needs a chance to equal 0. So one of these factors equals 0. So either x must be 0 or 2x minus 5 must be 0. So basically you're going to land up getting two answers because you land up solving both linear equations. So you solve these two linear equations because each of these factors happen to now be linear. So you've got little mini linear equations here. Now the first one's already solved because x would be 0. The second one, I need to add 5 to both sides, so I get 2x is 5, and then I need to divide by 2. So I get x is 5 over 2, which is 2.5. So those are our perfect steps there. First step, ask yourself if it's quadratic or linear. Second step, if it's quadratic, you need one side equal to 0, then you need to factorize, and then you need to give each factor a chance to equal 0, and you should land up with two answers. Okay, let's write our steps down as we do the next couple. So first question, I say to myself, is this quadratic or linear? This question is quadratic. How do I know that? Because it's got an x squared. Now you need to be able to talk yourself through this in a test. If you're not talking to yourself and you don't hear your voice in your head the whole test, you're probably not doing maths properly. So you need to look at it in the test and talk to yourself, not out loud obviously, but this is quadratic because there's an x squared. Right, what's the first step when I'm solving a quadratic equation? I need to get one side equal to 0. Now in this case, yay, it's been done for me. That's wonderful. What's my next step? My next step is factorize. I need to have two factors multiplied together to give me 0. So I'm going to check for a highest common factor, and x squared minus 9 does not have one. So next I check for a dots. Is this a difference? Yes. Is it of two terms? Yes. Are they both perfect squares? Yes, they are. So now we need to remember all our lovely factorizing knowledge. What does a dot say? A dot says the brackets are identical, except one's a plus, one's a minus. And we say to ourselves, what multiplies by itself to give you x squared? What multiplies by itself to give you 9? So x times x will be x squared, and 3 times 3 will give me 9. So get one side equal to 0, factorize. And my next step is each factor could be 0. So I'm going to get two answers by saying either x plus 3 could be 0 or x minus 3 could be 0. So my last step is to solve both of these equations. And so if I look at the first one, I'm going to subtract 3 on both sides, so I get x is negative 3. And the second one, I'm going to add 3 to both sides, so I get x is 3. And those are your 5 steps that you need to talk yourself through. So let's try another one. Eventually, quadratic equations become really easy. So, first step, oh my word, this is a quadratic equation because it's got an x squared. Second step, get one side equal to 0. So in this case, that has not been done for me. So I'm going to subtract 16 on both sides, and I'm going to get x squared minus 16 equals 0. Third step was factorize. Is there a highest common factor here? And the answer is no. Is it a dots? And I think it is a dots because x times x gives me x squared, 4 times 4 gives me 16, one's a plus, one's a minus. Next step is each factor could equal 0. So I'm going to take each factor and equate it to 0 in order to get two equations. So either x plus 4 must be 0 or x minus 4 must be 0. As long as one of them is 0, when you multiply by 0, you get 0. And so lastly, I'm going to solve my equations. So these are generally easy little linear equations. So I'm going to subtract 4 on both sides, so I get negative 4. And I'm going to add 4 on both sides, so I get 4. Now I just want to pause here for a second, and I want to show you what some of us will do and therefore lose a solution. Just like dividing by x loses a solution, what lots of people would do here is, let's just square root both sides. I mean, I've got x by itself, it's x squared. If I square root both sides, then I say x is equal to the square root of 16, which is true. And the square root of 16 is 4. Now, what have we forgotten? Technically, when you square root 16, you either find the positive square root or the negative square root. So technically, the answer is either positive 4 or negative 4, because negative 4 times negative 4 will also give you 16. So I personally never square root in an equation unless I'm desperate, because most of us will forget the plus or minus. So this works, you get exactly the same answers, and it works in this case only because this was x squared, there were no other x's. And so sometimes we forget when it works, sometimes we use it and forget the plus minus, so I avoid that technique at all costs. Okay, let's look at our last one. Our last one says x squared minus 64 equals 0. So this is a quadratic equation. I need to get one side equal to 0, which this already has done for me, which is wonderful. I then need to factorize. So I look for our highest common factor first, of which there is none. This is now another dots. So x times x, 8 times 8 will give me 64. One's a plus, one's a minus. Next step, each factor could equal 0, and then this would work. So there's going to be two answers, because either x plus 8 will have to equal 0, or x minus 8 will have to equal 0. So now I solve these two little equations, and if I subtract 8 from both sides in the first one, I get negative 8, and if I add 8 to both sides, I'll get 8. Now that's pretty much the end of our basic quadratic equations. This is a very, very important topic, so if you need to go back and push pause and really think about it, that's great. In the following lesson, we're going to do that exercise. So this has been a long video, so it's enough for one lesson. Let's just quickly recap those steps. How do I identify it's a quadratic equation? It has an x squared. Then I need to kick into quadratic equation mode, which means one side needs to be made equal to 0. So everything needs to move to the left, not just letters like linear. Everything moves to the left. Then I factorize, and then I give each factor a chance to equal 0. So after the next lesson, you would have practiced enough basic quadratic equations to move on to the slightly more difficult ones. Okay, well done everyone.